All right, in this video for grade 9 advanced science, we're looking at the worksheet on page 39 in your booklets called Volume Practice. This unit in science is called Volume and Mass, and so we're just going to practice some calculations that you might do in a math class regarding volume of things like cylinders, boxes, cones, and pyramids, and spheres, things like that. So page 39 of your booklet, I'm going to do a couple of questions here with you just to show you how your work should be laid out in your own booklets. So just make sure you understand some basic formulas. If you have a rectangular solid, so something that basically looks like a box of some type, so a rectangular based solid, then its volume is the length times the width times the height, right? That's a formula that everybody should understand. The length, the width, and the height of that solid. You might also have a cube. A cube is just another type of rectangular solid, and you could use the formula length times width times height also, but if it is a cube, then the length, the width, and the height are all the same. So in that case, you might just call them S for the side lengths instead of length, width, and height, and then you could say the volume of the cube is the side cubed, right? S times S times S, or S cubed. If you have a cylinder with a circular based top and bottom like that, then the volume of any cylinder is equal to the area of its base. This is a general formula, area of the base, multiplied by the height. Now, in this case, the base is a circle, and so that circle, the area would be based on its radius, right? So the area of a circle, the area of the base, is pi times r squared. That's how you'd find the area of a circle, and then you'd multiply that by h, the height of the cylinder. So v equals pi r squared h is the formula for volume of a cylinder. Now sometimes you have a shape that is drawn to a point, so like a cone in this case. Well, magically, this was proven by a mathematician named Archimedes over 2,000 years ago. He proved that the volume of that cone is 1/3 the volume of a cylinder that had the same height and the same radius. So basically, if that's the radius and the height is this height here, it's the perpendicular height from the base to the point at the end. So if you have a cone with a radius and a height like that, Archimedes proved that its volume would be 1/3 the volume of a cylinder with the same height and radius. So we already saw that that'd be 1/3 pi r squared h. Or take your volume of the cylinder, pi r squared h, and just divide by 3. Okay? Now you might also have a pyramid perhaps with a square base. Pardon my lack of artistry skills. So there's a square-based pyramid. It also has a height, right? And its base, if it was a square base, we could call both sides S. So now using the same logic, it would be the volume is the area of the base times the height. But using the same logic, because it comes to a point, we would divide by 3. So therefore its volume is 1/3, in this case, S squared times h. Okay? And finally, you might find questions that involve spheres, like a ball. Here's a sphere, right? The sphere has a certain radius to it. That same fellow Archimedes proved that the volume of a sphere is 2/3 the volume of a cylinder that has the same height and the same radius. Now that same idea, 2/3 the volume of a cylinder, can be rewritten, and it's usually written like this. It's 4/3 times pi times that radius cubed. Okay, the formula of a volume of a sphere. So those are some basic formulas for volume that you should be familiar with in advanced science. Question number 1 on the worksheet is giving you a picture of a cylinder. So it's got a circular base like that. It's got a height of 14.0 feet. And then it says that it has a diameter. So there's a dotted line across here. The diameter is equal to 32.42 feet. Now we're asked in part A to calculate the volume of that cylinder and express it in cubic feet. And we need to pay attention to significant digits. So let's start your answer by writing a formula for volume of the cylinder. As we saw earlier, the area of the base, in this case a circle, so pi r squared, multiplied by the height. There's the formula for volume of the cylinder. Now it wants the volume in cubic feet, so we can take the dimensions and plug them in the formula there. But we realize we don't actually know the radius. We know the diameter. So let's actually calculate the radius. The radius is 1/2 the diameter, or the diameter divided by 2. So we'll take the diameter, 32.42 feet, divide by 2. Now that 2 that we're dividing by is a perfect number, so we won't use significant digits rules for this. Since there's 4 digits in the diameter, we're going to keep 4 digits here in the radius. So that'll be 16.21 feet is the radius, half the diameter. So now we can come back here and calculate the volume. That'll be pi. I'll change that now to 3.14. I'm going to keep 3 digits in pi because the height, 14.0, has 3 digits. The radius has 4 digits. By keeping pi here with 3 digits, I'm not rounding off my answer more than I otherwise would have. If you want, you can also use the pi button if you have it on your calculator, times the radius, which is 16.21 feet. That has to be squared, and then multiplied by the height, which is 14.0 feet. So notice I have shown my formula. Then I've shown the formula with all the numbers plugged in. And now I'm just going to grab my calculator and do this on the calculator and put down the answer. So 3.14 on the calculator multiplied by 16.21. And if you want to use the squared button on the calculator, you can do that. There's a button that says x squared. Or you can multiply by 16.21 a second time, which is the same thing as squaring it. And then multiply by the 14.0. So my calculator shows me this really big number. In fact, I'll write that here. The calculator says 11,551.10984. That's what the calculator says. But of course, we need to write it, round it off appropriately. So since we're multiplying numbers and finding the volume, we're going to use the rule for multiplying and dividing with significant digits, and we're going to keep 3 digits, the smallest number of digits, in our answer. So you could round this off with 3 digits. You could call it 11,600, or you could call it in scientific notation 1.16 times 10 to the 4. Either one of those would be fine. Now, what units do we put? Well, one way to do this is to think algebraically, if you are familiar with this. Feet squared over here, feet to the power of 2, multiplied by feet means we're going to get feet cubed as the answer, cubic feet. Another way to look at that is just if you're finding a volume, the units will be cubic distance units. So for example, cubic centimeter, cubic meter, cubic inches, cubic feet. Those are all volumes. If you take the square of a distance unit, if you have square feet, square meters, those are areas. So you could have just argued I've calculated a volume, so its units are going to be cubic feet. So there's part A, and notice again, focus on how I showed my work. I've written the formula for the volume, I've plugged the numbers into the formula with their units, I've calculated the answer. You didn't really need to show me the number that was on the calculator itself, I would have just rounded it off and put down 11,600 cubic feet as my answer. On the side there, showing me how you found the radius is also an important part of the question. Part B says to convert your answer using unit multipliers to cubic meters. So we know the answer in cubic feet. What would the volume be in cubic meters? So let's set up some unit multipliers. I'll start by writing my answer, 11,600 cubic feet. And I'm going to want to convert that to cubic meters. I have no idea how many cubic feet are in a cubic meter, or how many cubic meters are in a cubic foot. But I do know about feet and inches. I think I can convert feet to inches. And I know how to convert inches to centimeters. I also know how to convert centimeters to meters. So I think I see a plan here. Now, one thing, if you're relatively new to unit multipliers, or maybe you haven't seen them for a while, we don't have feet in this question, we have cubic feet. So we're going to need to convert the feet to inches, not once, not twice, but 3 times. I'm going to put down that unit multiplier 3 times. So in the denominator, feet times feet times feet, that's going to be cubic feet, and that will cancel with the cubic feet that I had at the top. Now in the numerator, inches times inches times inches, that means we've converted cubic feet into cubic inches. Let's put our numbers in. The recipe for this would be that there are 12 inches in 1 foot, so you have to put that down 3 times. So because it was a cubic foot, we need the unit multiplier used 3 times to convert it to cubic inches. Do the same thing and convert it to cubic centimeters. Again, because there's not 1, but there's 3 inches in this string of multipliers, we're going to need 3 conversions to get to cubic centimeters. All right, so we're getting rid of inches by putting them in the denominator. They'll cancel with the inches that were in the numerator. And now we have centimeter times centimeter times centimeter. We have cubic centimeter. The recipe for this is a fact that everybody should know. 1 inch is 2.54 centimeters. 1 inch is 2.54 centimeters. 1 inch is 2.54 centimeters. So now we've converted, using 6 unit multipliers, cubic feet to cubic centimeters. With 3 more multipliers, I'll write that here on the next line, I can get rid of the cubic centimeters by putting them 3 times, centimeters 3 times, like this. Centimeter times centimeter times centimeter is cubic centimeter. That's going to cancel with the centimeters we had in the numerator earlier. And we can convert centimeters to meters. And again, 3 times because we want cubic meters. The recipe here, again, a fact that you should know, 1 meter has 100 centimeters. Remember that the prefix centi means 100. Like century has 100 years. There are 100 cents in a dollar, so there's 100 centimeters in a meter. 1 meter has 100 centimeters, 1 meter has 100 centimeters. So now on my calculator, 11,600 times 12 times 12 times 12, the 3 12s that are in the numerator, multiplied by 2.54, multiplied again and again 3 times by 2.54. And then, because the 100 is in the denominator, we'll divide by 100, divide again by 100, and divide again by 100, and press equals. All of the numbers in my unit multipliers here are perfect numbers. They're not measurements. There are exactly 12 inches in 1 foot. So those aren't measurements. There's exactly 2.54 centimeters in 1 inch. That looks a bit strange. You might have thought it was a rounded off number, but it isn't. It's exact. And there are exactly 100 centimeters in a meter. So those are all perfect numbers, so we ignore them when we round off with sig figs. Because the original number then had 3 significant digits, I'm going to keep 3 significant digits in this answer, and I'll write 328 cubic meters is my final answer there. So that's how your work should be shown to convert the cubic feet to cubic meters using unit multipliers. All right, so I've just done the first question on this worksheet with you. You need to complete the worksheet. This is a bit of a coronavirus year, so I'm going to assign some fewer questions. I want you to finish questions 2 and 3, questions 6 and 7, and question 12. Okay, so you can finish those 5 problems for yourself as homework. Good luck.